Okay, so for today, those of you that have used Mathematica before in the past, I think a little bit of this might be review, but um, toward the second half, I'll almost definitely get to some new projects that we're doing, especially related to our cloud technology. So I would expect that that will be new to you. And for those of you that are completely new to Mathematica or Wolfram Language or our notebooks, this will be a much more comprehensive introduction to what we're doing and how things work and really how to make the most of these notebooks. So the first thing I want to point out is I'll give this presentation on my local machine mostly. I'm going to hop back and forth to web browsers a little bit, but in Mathematica and in Wolfram Language, but Mathematica specifically is what you're looking at here. Notebooks are a very nice what you see is what you get environment. Um, a lot of people build them up as just documents with a mix of text and calculations and things, but there's also this real nice slideshow environment. So when I give presentations, and I say this, and sometimes people think it's hyperbole or that I'm joking, but I really am a very poor PowerPoint user. I have very little notion how to actually use it. So if I want to do a presentation, it almost always has some thing that I want to do as live computation, or someone will ask a question and I'll type something. So the slideshow environment in Mathematica, so if you go to new presenter notebook, that gives you a nice template to fill in for this nice slideshow. It's all the same, where it's all the things that I talk about in a regular notebook are also true in a slideshow. The difference being there's this advancing one slide, advancing to the last slide, or a drop down to fast forward to slides, or taking over the full screen, or things like that. So if I speak as if I'm speaking only of regular notebooks, keep in mind that the slideshows and all these things, they are true for all of these environments. So as a quick outline, I'm going to go over the notebooks. I'm also, as I mentioned, going to go over collaboration and sharing. That basically boils down to how do Wolfram notebooks work when you want to put them on the web and then basically communicate a final project. So if you know that your collaborator or the recipient of a notebook has Mathematica installed, if they're at MIT, it's a pretty simple process to send them a file, a notebook file, and then they can open in Mathematica. The question though becomes, what if they don't have Mathematica on that machine? What if they're looking at their example, your example on their phone? Or what if you're collaborating with someone outside of MIT and you're not sure if they have Mathematica or what version or something like that? So this is the newest sort of world of Wolfram notebooks, where not only can you make them much more portable, but you can also make really nice web forms in addition to our notebooks as well. So I'm going to leave the notebook theme a little bit at the end, but for the most part, I'm going to go over the scope of what you can do in notebooks. In terms of technology and products, I just want to quickly mention that we use the term Wolfram Language a lot. We use the term Mathematica a lot. Wolfram Language is the underlying language that has always been in Mathematica. So sometimes we use one term or the other. If you've got Mathematica installed on your machine, you've got Wolfram Language. Um, uh, After you leave MIT or after you graduate from MIT, keep in mind that there are other ways that we license Wolfram Language, one of which is our Wolfram engine for software developers, one of which is a product called Wolfram One. There are more sort of pay-as-you-go options. There are more ways to embed computation as APIs, things like that. So we use this term Wolfram Language where outside of academia, where there's a long-standing history of Mathematica site licenses. But outside of that world, we talk about Wolfram Language a bit more. So if I use the two, I just want to make one meta point about how they fit together, that there is a lot of overlap, but that in some senses, um, they can be different and diverge as well. Okay. So let me go through a couple of the basics of notebooks. So a notebook is a structured document. And let me move this camera here a little bit. Okay, so the structure is delineated by what we call cells. So these blue brackets here are cell markers. You can have text cells. These are item cells. This is a subsection cell. You can switch the type of cell. I'm actually pressing a keyboard shortcut here to do this. Or you can go to the Format drop-down menu and go to the Style, and then you can see all the available types of cells, many of which are just nice title, subtitle, chapter, so they've got different coloring, different sizes, different fonts sometimes, but they're just a really nice way to structure a document. Cell may contain text or code or math or images or some combination thereof. So if you've got a cell where you want to do a simple command, this is our first this is our first input cell of the day. So this is a item cell, this is a text cell, and then this is our first computation. For those of you that have never used Mathematica before, you hold down Shift and hit Enter to evaluate a cell. It can be one calculation, it can be a series of calculations, it can be an image processing calculation or whatever. Whatever's in that cell, when you hold down Shift and hit Enter, it will evaluate that. So this is a string of text. The string reverse command simply reverses those characters in the string of text. A cell can contain images. So this draws from our example data. Every time you install Mathematica, it comes with a whole suite of example data, audio files, image files, text files, things like that. This is a 3D a 3D rendering of some sort of engine or something like that. So I can drag this, I can rotate this, but the overall point here is embedding images, even 3D images, in an output cell. It works just like any other cell. So an output cell, the result of a calculation could be something mathematical, could be a string of text, could be a graphic, but in terms of the workflow and the structure of a notebook, it's all the same. And then, as I mentioned, this one is more mathematical, where we're solving this equation with coefficients A, B, and C here. And then what we get is a list of rules. We actually get a list of lists as the output, each of which is an equation. Also, another note too, this is a code comment. So sometimes people ask, how do you write a Wolfram notebook where you comment your code? I always have two answers to that. Personally, when I comment code, I just start a text cell, basically. So when I'm making a document or a presentation, I am almost always explaining something. So I want to explain, here's where this data came from. Here's the good things about that data source. Here are the caveats about that data source. Here's the computation, here's the pre-processing, here's a chart, here's what I think we've learned from the chart. But in general, I'm not writing code and having a chart, but it's one big block of code. I'm almost always giving a presentation, or I'm having someone read through that where I'm not available to sit there and talk them through it. So that text and sprinkling in that text is almost 100% what I do in Wolfram Notebooks. Now, there are some cases where you do want to write, you just want to use Wolfram Notebook as more of a IDE or a code development environment. So in this input cell here, we run this calculation to import this, but this is a code comment. So this is within the input cell, but it's something that's not evaluated when you run that calculation. So if you do want to have one big block of code, but have interspersed code comments, that's the syntax on how you do that, that parentheses star at the front or the back of that. Next thing I want to talk about is the structure of notebooks is hierarchical. So cells can be grouped or collapsed. And again, this is very useful to me when I give presentations. So sometimes I'll have a lot of information all at once, but I don't want people necessarily reading ahead. So you can double click on these cell brackets. You can see this is a subsection. This is a item. And then there is a cell bracket that that is hierarchical and represents the cell group. So if I double click on that, it actually minimizes that item content. And if I double click on it again, then I get that content back. So if I've got something where I've got a couple different talking points, one of which might be prepping data, one of which might be visualization, one of which might be conclusions, I don't want you reading the conclusion right from the start. So I will often double click just to minimize the conclusion. Then you're thinking with me, you're following my narrative throughout, and then I can reveal that content at the end when I want to. These hierarchical structures, so this applies to calculations as well. So if I double click that cell grouping for an input-output pair, it just minimizes the output. I don't do this very often, but sometimes if you have a calculation where maybe it takes 10 minutes to run and you don't want to run that live in front of an audience, but you want to minimize it and tuck it away, you can do that. I more often double click on an output to minimize the input. So if I have a chart, but I just want people to look at the chart, if they want to see how I created the chart, they can double click and see that and rerun it themselves or change it or tweak it, and that's great. But in the context of a presentation, I'll often double click just to show the output, which is a table of data or an equation, or as I said, mostly a graphic. But then that provides a nice clean presentation format. And you can double click on multiple things. So this is a subsection, this is a section. I've double clicked a couple times here. When I double click to reveal, that subgroup here is still minimized. I can click on this to reveal that, and so on and so on. So as I said, it's hierarchical, where the higher the larger and higher that you go, that is the thing, the division on the outside that's the highest in the subgroup, basically. Notebooks are defined by what we call style sheets. So there's a couple ways to adjust the formatting of a notebook. So the first and probably the most common is, if you just want to do something, you can think of this like OpenOffice or Word or something like that. If you want to do something like change the font or the face or the size or the color or the background color or something like that, you can do all that just with the drop-down menu, the format drop-down menu. So for example, if I want this to be italic, there's a standard keyboard shortcut for that, of course, but I can change that to italics. I can change this where, let's say I want the color to be blue or something like that. Maybe I want this to be underlined or something like that. But again, that's commonly how people change things. You can also highlight one entire cell and do something like change the font. So if I go to font here and I want to change this to something very dramatic, then I can do that. So you can make changes at the cell level. You can also make changes at the full notebook level. And I'm actually going to start a brand new notebook here so I don't fool with the presentation too much here. But if I go to Format and then Style Sheet, this is more global settings. So if you want to change the look and feel of the entire thing, not cell by cell, but the entire notebook, there's several things that you can choose from here. So for example, if you want to go to a report and change it to a standard report, you can do that. Or let me go to the one that's like a journal article. Yeah, so that looks mainly the same, but if you've got numbered formulas or things like that, then that looks a little bit different. The default is what we were at before, and that's the one I use most often. There are some that are much more dramatic as well. So let's see, where are they? It's oh, reverse color is another good one. Yeah. So if you like dark screen, reverse color is a nice one, but there are ones where it colors the background yellow and all sorts of things like that. So they do get more dramatic than what I was just showing. You can make your own style sheets if you want. So if you want to start up a notebook and you always want to have your fonts the same, which are different than the default, or if you want to have the sizing a very specific way, you can actually go in and say, edit the style sheet, and you can customize each type of cell to be to your liking. And you can either save that, you can embed that style sheet in your notebook, or you can embed it where all new notebooks are of that type. Generally, I do notebook by notebook by notebook, but that's a nice way to do things as well. One project I was involved in, we created I'm co-author of one of the main reference texts that's on Wolfram Media. So we created a custom style sheet for that book. So I'm describing this in the how to get started format, but this idea can be applied to very, involved projects. So in our case, we did a chapter of a book. Each chapter was a note. Yeah, each chapter was its own notebook. So each had its own custom style sheet. We wanted different types of cells that have a spiky icon and things like that. Um, so it was a very customized style sheet. And then when we turned that over to our production team, they basically went from notebooks to PDF with some light graphic design and then sent it to the printer. So our notebooks are useful for computation. They're useful in the Wolfram ecosystem, but they're also very useful when you go outside of the Wolfram ecosystem as well. And I'm a pretty good example of a real, when you look at my book in the Kindle store, you're seeing a PDF of notebooks. And there's very little other magic that goes on behind the scenes there. Okay, so notebooks can help you track the history of your computation. So there are in and out markers. So when I evaluate this, this is my 5th calculation of the day. So it's in 5, out 5. Inputs and outputs from earlier sessions have just blank in outputs. And then if you change an input, but you already have the output there, it will gray out the output just to give you that good cue that you've changed something and that you've got a mismatch there. You can also undo. So edit undo, there's multiple undos, but that also keeps track of the kernel state, so the actual solver of Mathematica, as well as in Wolfram Language, as well as the Wolfram notebooks that you're looking at. So if we quit the kernel here, as I mentioned before, these in-outs will go blank. If I reevaluate this, then this will launch the kernel for the first time today, and it will revert to in one, out one as the first calculation of the day, which it's taking a little bit here, but there we go. Okay, good. And then if you have a 3D plot and you change that, although this doesn't happen in the presenter tools in the slideshow, but in a regular notebook, if I were to change this to sign, it would gray that out. And then when I reevaluate, then it would turn back to colored. So then you would know if you have a mismatch. Okay, so another thing, and this gets a little bit more drilled down. So there's a really nice authoring experience to notebooks. So that can be command completion, that can be suggestions for next computations, that can be code editing and just double clicking on things. So one thing that people see me do a lot, and I'm bad about just stopping and explaining this. So I will double or triple or quadruple click a lot. So let's say I've got a computation and it's one command wrapped around another, wrapped around another, wrapped around another. So the core of this starts with Cellular Automata, where we're taking Rule 30, we're creating an array plot, we're doing a transformation. This manipulate creates a GUI. So we're going to manipulate some parameter and recalculate and redraw this. So let's say I'm missing a bracket or something like that. I will a lot of times just double or triple or quadruple click just to see, okay, this array plot part, I can copy that, I can paste that into a new notebook. Okay, great. As a standalone piece of code, that works. If it did this, then I would know that I've got an error here where this bracket is highlighted, which means I don't have a closed bracket that that is the pair of that. And so it helps with debugging, it helps with troubleshooting, it helps figuring out what's going on if you're wrapping one function around another around another. In addition, I mentioned the code completion is nice. So if you've got something like plot, if you just start to type in a Wolfram notebook, it will say there are several examples, built-in functions in Wolfram language that start with PLO, for example, plot, plot 3D, plot range, etc. Then I can click on this. I can click this caret to get a template. I can choose the common syntax, the common form, and it will paste in a template for me to fill in. So plot wants a function. There's a variable of interest with a min and a max. So here in this case, I can just go through and fill this in like x squared. I can tab. I can go 0 to 10, and then I can evaluate that. In addition, and I've got this minimized here, but yeah, let me go out to a regular notebook. Okay. Yeah. So there's a suggestions bar as well. So after you calculate something, you could add in some labels. For an axis, you could adjust the image size. You could add a theme. If I want to do a scientific theme, it gives me a preview of that. I can hit done. But if you want to customize a calculation, this suggestions bar is a nice way to do that. Some of these things that I'm showing, I'm flipping over to a regular notebook. When you're doing a presentation, some of these things are by default turned off because you want a nice clean presentation. You don't want a lot of things flashing or distracting. So in some cases, that's the sole reason why I'm clicking from this presentation off to a regular notebook to demonstrate these things. You can also embed data. So if you want to reference an external file, you can do that. But if you want to embed data right in the notebook as well, you can do that. Oh, thanks, David. So in the chat, I'll try to watch the chat between slides and pick up questions, but thank you for answering, David. So if you want to embed data, you can just reference the data, and you can do this thing that we call iconize. So instead of printing a huge thing of data to the screen, iconize is basically a way to wrap that in a nice little label so the data is there, it's embedded in the notebook, but it doesn't take up a lot of screen space, which is pretty nice. And you can also turn outputs into inputs, which is nice. And yeah, you can use inputs to embed things. So here's one example where we're going to import something where this is just, we're going to import a image file. So this is just an image where the output is an image. And again, you can turn, I can copy and paste this output, and I can just turn that into an input if I want. So if I want to say image equals and then I'm just doing copy paste here, literally Control C, Control V. If I want to say image equals, so that for the next time, if someone else wants to run this, if it's some sort of image processing computation, something like that, rather than relying on, I mean, this is the Wolfram website, so this image probably will be there long term, but if you're pointing at the web, there's always the danger that that website is taken down, it's not there, and so then all subsequent calculations break because you can't reference that first image. So this is basically a way to say, this is now referenced in the notebook. I could even put a semicolon after that to suppress the output. And then if I say blur image, then that image is referenced, and then I can reference that, or I can blur it 10 times or something like that. But then just basically the meta point here is this approach helps things work from a cold start and organize and collect your data which is very useful. This is downloading some data from GitHub. So rather than an image, this is downloading a lot of tabular data where I'll download this live. It takes a little bit here, but it's something like 100,000 or so rows and a dozen or 2 dozen or 3 dozen columns, something like that. But it's data related to the MBA, so it's a mix of numbers, a mix of strings, but it's basically tabular data. And so again, I'm relying on GitHub here, which hopefully that data will stay there and it'll be pretty, um, um, pretty stable. But if I wanted to do something like reference this, and here I'm iconizing this, so I'm now able to embed this, and I can say data equals this iconized data. And then if I evaluate this, then this is now stored as a symbol, and then I can do things like extract parts of the data or find patterns in data or do sentiment analysis on the strings in the data or run some statistics on the data or whatever. Now here, if I say data equals, this just tried to print the entire thing to the screen. And we can see here, instead of printing 126,000 rows to the screen, by default, a notebook abbreviates here and says, you probably don't want to visually inspect 126,000 rows. Here is just a little bit of it, and then it gives me an option to show less or show more or something like that. But it sort of saves me from myself there. Next thing, so, and I'll show a couple examples. This will make more sense going through the examples, but Wolfram Notebooks are themselves computable entities. So, and again, this gets a little bit subtle, but a notebook can be a source of data. So sometimes I do save data in notebooks. You can import notebooks. You can use a notebook to import a notebook. I mean, the question is, why would you want to do that? Sometimes if you've got data where if you're saving to a spreadsheet might automatically numerically approximate some of your data, or it doesn't represent images, or a notebook can have all this rich data and it's all available in a real convenient format. So importing or using it as a data source is pretty useful. The other thing, the other aspect of notebooks being computable is you can programmatically create or change notebooks. In practice, I find this comes up mostly in creating dashboards or data science. Maybe that's a sign of the times, or maybe that's just a sign of the questions that people are asking, and maybe that's not the best representation of what people are doing. But if you want to do something like you have a notebook, it has some data, it draws in some new data, maybe it runs every day, it makes a dashboard, but instead of having that dashboard be a PDF, just a static run of the view of today's data. If you want that dashboard to itself be a notebook, you can use a notebook to programmatically create other notebooks, both of which have live computations, which is pretty cool. And so if you look at a notebook and you say, let's highlight this, this, and well, let's just start with this one. So if I highlight this and I go to cell and I say show expression, this is behind the scenes what the Wolfram language representation of that cell in a notebook. You can see that cell is itself a function in Wolfram language. And there's text data and there's strings, there's different boxes and styling and things like that. This little item, it's a second argument to cell that denotes that it's an item, and so on and so on. If there was, it's bold, if there was coloring, it would be listed here, et cetera, et cetera. But all this, we're looking at I mentioned notebooks are very much a what you see is what you get. If I start a text cell here and I just say this is a text cell, I can very easily type things in. It seems very clean and easy, but there's a lot that goes on behind the scenes where a lot of this lower level stuff is just created by default, which is pretty cool. Now, if you want to use this where, let's say, I say C equals evaluation cell, so that means we're talking about this cell here, and then I say, let's change the background of that to light blue. If I run this input, it actually changes the background color to light blue there. So before I was going to the format drop-down menu and I was adjusting those kind of things, but you can programmatically change those kind of things. Or if I say, let's import the notebook that I'm in right now. So the evaluation notebook that we're looking at, and then let's take all the items and let's display them. And then list picker is a way to display those in a nice box where I can go up and down. So what's happening here is I'm reevaluating the thing that I'm looking at. It's going through all the slides. It's finding all the cells with this specific formatting, and it's going to give me a list of them. So again, it's a way to use a notebook as a data source and extract data from the notebook itself. There we go. So these are all the cells in the entire thing. There are a couple coming up where I'm talking about web forms. We haven't gotten to that part of the presentation, but again, this is extracting all the data, which is pretty cool. Notebook read of C, again, I mentioned that you can look at the cell expression. This is this input cell, and if we say notebook read, we get that similar thing, but now we see their background goes to light blue because we changed that before. But this is the way to programmatically do what I was doing before, that cell show expression. And then if we want to start to alter things, the slash dot is the shortcut for replace all. So we're actually using pattern matching here. We're saying grab this cell, and where you see C, replace that with the cell. So before we had C equals evaluation cell, and now we have the cell equals evaluation cell. So we've created a new cell here based on that other cell using replacement rules, or actually Wolfram language constructs, to alter the content of it. Now, these are a few more applications, and I mentioned in real world practice, a lot of times this comes up in creating dashboards. So another function is create document. So rather than writing new content to just this cell, I'm going to create an entirely new notebook. So when I run create document, it programmatically creates a new notebook. I'm going to make a text cell of today's stock comparison. I'm going to embed some data from Wolfram Alpha. So I'm going to use the built-in Wolfram Alpha functions. These are the same pods that you would see if you go to wolframalpha.com. But if I want to make a dashboard where this is programmatically emailed to a certain group every day, maybe it's different stocks based on some pattern or some criteria that we're looking at. But the final form of this could be something where I've got a section, I've got some text, I've got some stock information, I've got some time series data. I can actually go here and click on this. So this is a live computation where I can lean on the Wolfram Alpha data. But if I click on this, oh, there we go. Okay. So if I go to the last 2 years, I can get different time series data. This is using that Wolfram Alpha data where it's going to our servers. It's downloading that new data. It's taking a little bit because I'm sharing over Zoom here, but yeah, there we go. So we can see that this is, of course, a very interesting point in time. But anyway, the meta point here is I can programmatically create section, subsection cells, text cells, and then live computations all in one notebook, and then send those to people. I seem to be running into a little bit of a bottleneck. There we go. Okay, let me just close that down. Okay, this other thing, this is going to create another notebook. Again, I'm using create document with text cells. This is going to download a lot of data from country data. So it's using our curated data sources. Country data is a built-in function in Wolfram Language where there's a whole team of people at Wolfram that is curating the world's data. We have trillions of bits of data built into the language. Some of these things like chemical data or data on planets, they don't change an awful lot, so they're pretty stable over time. But other things like the population of France gets updated over time. We have data on universities, so you might want to compare MIT to Harvard to another university, but this happens to use country data where we're downloading data for all the countries in Africa. We're downloading the geometric shape. We're downloading the population. So we're going to display a time series, 1970 to 2005, as well as the shape of the country. We're going to put that all in a notebook. There's going to be a window title, and we're going to save it as natural color, or we're going to actually style it with natural color. So we're going to give it a custom style sheet. So this takes a little bit where it's downloading and preloading and embedding all this data. But when this is done, then we can compare different countries to each other. And again, I'm using Wolfram Alpha data or Wolfram data here. This could just as easily be your own data or a mix of your own data along with Wolfram's data, or something that you draw from a SQL database where you query this every day as data is added to that or something like that. Yeah, sorry, with me sharing on Zoom here, it takes a little while. Okay, so now we have a notebook where again, there are collapsed cells. I can open Algeria. I can see the shape of that. I can see the population over time. And then I can compare that to other countries. I can close that back up. I can skip down to the list. As you can see, it downloaded data for a lot of different countries. Um, I might want to compare that to Western Sahara. So this is much less linear in terms of population growth. There seems to be something maybe historically significant or something to do with socioeconomic conditions, or there's something where this might be an interesting point, this might be an interesting point, and this might be an interesting point. But again, that's the point of creating these notebooks, embedding this data where you can programmatically create this and then start to ask interesting questions about the data. Okay, I'm going to go through the next couple slides a little bit more quickly. I've already done a manipulate, but one thing that manipulate is really good at is creating mouse-driven interfaces. So if you want to guide a computation in a certain way, where let's say in this case, we're going to take an image, we're going to change the coloring of that image, and then we're going to take a look at that restyled image as well as an image histogram to take a look at the color. This slider controls the coloring and it controls that where as I move this slider, all of those things are updated dynamically. Manipulate works with anything in Wolfram language. So it could be data, it could be mathematical things, it could be a graphic, it could be something related to deep learning. Manipulate is just a great way to vary some parameter and in real time see the effects of that. That parameter could be part of a computation. It could be adjusting the timestamp of a graphic or whatever. You know, whatever you can imagine. Manipulate should be pretty good at helping you visualize it. It's in general a really good way to do simulations or models or animations in the language. Okay, so now that we've gone through mouse-driven GUIs and kind of the theme is finished projects where we're programmatically creating notebooks or creating GUIs, I want to shift here to sharing projects and then talk a little bit more about the modern projects, especially the things where we're embedding notebooks in the web. So I'm going to talk about a couple things here. One thing that we talk about is deployments or published notebooks. And again, this is a generally something where you put a notebook in the web, you can embed mouse-driven applications, you can embed data, you can include all those things like text and um, uh, explanation and inputs and all that kind of stuff, everything that I just showed in a notebook. You could also create a totally separate web form if you wanted. So notebooks could create web forms, but the notebook format, again, can have all these rich elements, these nice what you see is what you get elements. If there's typeset math, that converts pretty nicely, very nicely as well. And then there could be live computation with mouse-driven applications. So let me start with just a real simple example here. Um, so this is a totally separate notebook. It's just something that I created at one point. I think I created this originally as a proof of concept for someone. It's just a simple optical illusion. So if you take these geometric shapes and you shift the rectangles, so if you offset those, the optical illusion here is that this line and this line and this line no longer seem to be parallel lines. It seems like they are skewing out, basically, um, to a greater or lesser extent. So maybe you want to explore that, where if it's a black line, uh, that that is definitely present. If it's a gray line, seems to be even more pronounced to me, actually. If it's a orange or blue line, well, it looks about the same. If it's white, white seems much less pronounced. So this is just a way to create, and again, I created a manipulate here. The core of this is manipulate graphics primitives where I'm drawing rectangles, I'm drawing lines, and then I'm swapping in different colors, or I'm bumping the images in a certain way. So the other thing that I can do here, if I go back, and maybe this is a bit more explanation than you need here, but I can bump this where it immediately ruins the optical illusion. So as a viewer of this, I might think to myself, I'm not so sure I actually trust that those are parallel at this point. But if you bump, then all of a sudden the optical illusion is broken, and you can really see that um, that the geometry of it really does stay uniform. Anyway, long explanation. But if I wanted to share this with people, I could, of course, email this notebook. I could send it to people. People could reevaluate this. They could change it. They could tweak it. They could work with it, etc. But one thing I could do as well, and especially for people where I'm not sure if they have Mathematica or not, the most simple modern way to share a notebook now is to do what we call publish to cloud. So when I publish this, and again, um, people are talking about notebooks a lot now, and notebooks in terms of Jupyter notebooks and notebooks in terms of all these other projects. So I find this a very clean way to do a lot of things, especially where a lot of these details of, does someone need to download something? Do they need an engine to run this? Or do they have to run a web page locally? Or do I have to host it somewhere? Or how can I host it, or whatever? All I do is just publish to cloud, and all that stuff just works. So if I click publish, it creates a public URL. It's hosted by Wolfram. I can change the name if I want, or I can password protect it if I want. I can embed this, so it gives me iframe tags. But let's just view the page here. This is just a great way for me to post something. Maybe if I'm doing a research article, I can reference this URL in the article. Maybe if I'm teaching a class, I can put the URL in Blackboard or Moodle or Canvas or something like that. I could put this, and I do this all the time, where if I have a conversation with someone, and then I'll go to the chat pod, and then I'll just pop this URL right in the chat. Um, so in real time, I can discuss something with someone, I can make a proof of concept, I can publish this to the cloud, and then people can grab it. The really nice thing is that anyone in the world can run this. It runs really nicely on a phone or an iPad. And if you just want to interact with this and move these sliders, anyone in the world can do that. I, as the author of this, I've got the licensing where I'm supplying this time in the Wolfram servers to do that. But if I'm collaborating with someone and I have no idea if they have Mathematica or use Mathematica, this is a great way to do things. Now, for everyone here who I would guess either has Mathematica or could download Mathematica immediately or could get Mathematica online immediately, you can download this notebook and run it locally on your machine. If you click make your own copy, that prompts you to go into Mathematica Online, where all these Wolfram Notebook elements are in browser here. So now I've just logged in. I've made a copy of this file, so I'm no longer adjusting the original, but now all these text cells are live. The computation is live. I can peel into the computation here. I could change something if I wanted to, but this is now copied to my cloud account, and I can work with this. So there's a really nice balance here where if you've got a finished project, people can read through what you've done. They can do some calculations that you have in a mouse-driven format, but if they want to take the next step and really adapt to your calculations or use it as a jumping off point, it's then really easy to copy this into my account as the recipient, and then, away I go. Where again, that nicely leads to collaboration. All right, I've got all right, so that is basically what I mean by deployments. The other thing that you can do, and I'll probably gloss over this somewhat quickly, and then, and again, definitely fill out that registration for the series, for the IAP series, and then I'll send you all the inputs and all of this as well, and you can read more about this. But if you're collaborating with people where they've got Mathematica online, you can actually name certain what we call Wolfram IDs. That's people's logins. It generally is their email address. So if I was collaborating with 10 of you and you have at mit.edu or at Harvard or at BU or whatever Wolfram IDs, I could actually name certain Wolfram IDs, and then immediately I'm sharing a full notebook with you as you make changes or as another person makes changes. If I look at that notebook later, those changes are happening to that same notebook. It's a really great way to collaborate. If we're all divide and conquering on a research project and somebody's doing the pre-processing of data and someone's doing the charts and whatever, but we all want to put that in one notebook, that's a great way to do it. Okay, so I'm going to start to run through some of these more quickly here. So this is a way to embed manipulate into a website. Again, you can do that by publishing, or you can do that with this. But I'm going to skip ahead and I'm going to wrap up here with web forms. So yeah, so this function cloud deploy is a high-level function that creates web forms for live computations. It is essentially writing HTML for you. So that can be really convenient, again, if you want to iframe something or if you want to reference a live computation. For example, in this case, I might want a web form that I can send this to anyone in the world. They can upload their CSV file, their live data. It creates a histogram of that. It creates a description. It's got a title. I can set the permissions where public means anyone in the world can run this. But if I click on this URL here, this again is hosted by Wolfram. The URL starts wolframcloud.com/object. So I, as the author, am creating this and I can send this to anybody. But the recipient Um, and again, the compare contrast here is this is creating a website. So in a lot of cases, a Wolfram Notebook and people looking at the Wolfram Notebook is a great way to do things. But in this case, they're not even seeing the Wolfram language or the code behind the scenes. So if they upload a CSV file here and click submit, this web form does a calculation on Wolfram servers. It returns a result here. So this is the histogram where I can see I've got 4 values in this bin, I've got 4, I've got 2, I've got 1 in this bin, et cetera, et cetera. But this is something where you can truly tuck away the Wolfram language component of this. So you can create web forms, you can create REST APIs, but if you want to work with Wolfram language, and again, this is a little bit off topic of notebooks, but you can use notebooks to create code even if that code, the deliverable of that code is a REST API, or even if the deliverable of that code is a web form. So Wolfram Notebooks can be a final point where a published notebook is a great thing to share with people, or a Wolfram Notebook can be a good development environment, even if the final thing is a PDF that you send to someone, or you export an image as an EPS, and that's the final thing for the notebook, or it's a web form or something like that. So I just want to make that meta point that sometimes Wolfram notebooks are the starting point and the ending point. Sometimes they're the starting point, but not the ending point, and all mixes in between, basically. I want to show one final example here of a cloud deploy. So if you've got a real world project here, and I took this from the Wolfram blog, it's a project where you computationally want to take something like this image. It's got a lot of blood cells here. And let's say we want to computationally count these. We might want to do this over and over and over again. We might want to write some code where we are giving this to a biologist or a lab tech or someone where they want to be the user of the application, but maybe they're not so concerned with the Wolfram language code today. They might want to review it and vet it, but they might just want to be a consumer of the application. So this is a quick compare contrast. So in terms of notebooks, this is a notebook that has all the traditional elements that I've gone through. Again, Wolfram has done notebooks for a bunch of decades now. So this is something that people have done for a long time, where there's text, there's a hyperlink here out to this blog. I'm embedding this image, I'm storing it as a variable. There's some segmentation analysis, some further image processing, some coloring of unique elements, some drawing of circles and numbering here using graphic primitives. There's a histogram that's created. There's some custom styling. But the whole point here is, it's a narrative. There's some text, there's some computations, they're one step at a time. You can figure out, where this thing is going. Now, if you just want to make this as a final application, all of this and this through this, so all of this is a repeat of what was on the last slide. So instead of that being cell by cell by cell by cell, step by step by step by step, this is just one compound input with semicolons separating it, but it's all the same stuff. It's got cloud deploy and form function wrapped around it. Form function is a web form that is going to expect the user to upload their own PNG file. They can set some sort of bin width for the histogram, and then the program just references that uploaded image and draws a cloud form. So when I click on this, I've now, left the local Wolfram notebook. This is now on wolframcloud.com. I can send this to anyone in the world. They can upload their own different slide of blood cells. They can input their own parameter. I think 25 always works out to be pretty good. I can click submit. So when I click submit, it's going to upload that image. It's going to run those 12 to 15 calculations related to image processing and charting and statistics and all that stuff. And then it's going to give me a grid of graphics as the result here. So I can visualize I'm using this Wolfram language algorithm in this web form, where now I can visualize that same the same overall idea, but based on new data. And this would be something where I do this over and over and over again. I might want to collect this data. There's good ways on our servers to say, let's store, if people are going to upload 100 images, let's store all of those. And then, later in a Wolfram notebook, you can do some aggregate analysis or something like that. But anyway, I'm sort of running through lots of permutations rapid fire there, but the meta point is the Wolfram Notebook is a way to develop that algorithm and that web form, and then that's usable to anyone in the world. And me as the Mathematica Online and Wolfram Cloud user here, I've got the time on Wolfram servers to fuel that computation. I've got a pool of time, and then anyone in the world can just run this computation. So I just want to run through that in some amount of detail, because I think sometimes Wolfram Notebooks are seen as um, only specific to within Mathematica. Like you have to be a Mathematica user and have it and have a site license for it to be worthwhile. But starting, I would say probably 2, 3, 4 years ago or so, um, that whole story has changed an awful, awful, awful lot. Everything is much more portable, both in terms of what you can do to embed code or share notebooks or create websites or web forms. But if you want to leave that world of just sketching up things for yourself and sharing things, still Wolfram notebooks are or Wolfram notebooks are a great way to do that. I think they've always been a great way to do that, but they're even more useful now, even than they were 5 years ago or definitely 10 years ago.